warm welcome. This is Timon. This is Startup School. This is Generative AI. Welcome to our fifth session, if I count correctly right now. Who would have thought? We're almost in the middle of Startup School, and we meet today in class for a topic of embeddings and vector databases. I'm super thrilled to see thousands of you joining today to discuss what embeddings are, how they are useful, how we will use them with vector databases, how we'll apply them. It's all in front of us today. Of course, for those of you who've been here for a couple of sessions now, you know that there is a little bit of a housekeeping and a little bit of me in the beginning. So let's go ahead. Just a quick reminder about our structure. You are taking part in the live session right now. Every Tuesday, every Thursday, we are meeting live, and we are recommending some kind of a homework for you to do. Now, we've received a lot of questions about notebooks, so just let me explain a little bit. The labs for some of the topics and for some of the sessions are available in Cloud Skills Boost that you all received access to. We also have notebooks as a kind of the homework. It's not obligatory to run the notebooks. Notebooks are a great source of knowledge and a way to practice your knowledge, but you need your own Cloud Console to run notebooks. Contrary to labs and Skills Boost, where you can just run a lab, you will need your own Cloud Console. There might be available elements, so we strongly recommend to start a free trial or use the cloud program that I will mention later on. Every single lab, every single notebook is listed under this link that you should be all familiar with. So it's go.gl/genai-labs. Housekeeping rules for us, mostly for those who are here for the first time. Q&A, as always, available for you below the screen. You can post your question, and we have AI experts that will answer. Don't worry if your question is not showing. We have moderators in the backend, and we want to make sure that the questions are right and they're not abusive. So we have a slight moderation before they are posted. Each class will end also with live Q&A. We will ask the most common questions to our instructor of the day. Most of you, I know it. We are available on demand, but this particular recording, will be available in about 8 to 10 hours when the end of the day is in the US. When it comes to Skills Boost, I will mention this right now, but please don't try to access the code labs or the notebooks right now. Now it's your time with the instructor. Cloud Skill Boost, we strongly recommend to use it to learn more about generative AI, but also other topics related to cloud. I know, and I've seen how many of you completed the labs already, but for those of you that still missed that one link and have some troubles, here's a backup QR code for you and a couple of instructions. If you're not able still to get the access, please write us at startupschool@google.com or directly to support at Quick Labs. We also recommend to take a couple of additional labs over there in your free time. You can earn an amazing skills badges for completing selected labs. You will see which in a filter many on Skills Boost. And with that, I would love to invite to the stage our amazing engineer, staff developer advocate, Cass Sato, that will tell us a little bit more today about this embeddings, how it can help your machine learning, what do we understand, and how we can include new data sets using those, and how to use and store them in vector databases. A lot, maybe it's complicated, but for sure very useful. That's why we're inviting the best of the best to explain all of this to you. We will see each other in about an hour, I guess, for the Q&A. But for this whole hour, Kaz, the floor is yours. The audience is yours. Good luck.
Thank you, Timon, for the introduction. Hi everyone, I'm Kaz. I'm a developer advocate from Google Cloud team. I'm based in Tokyo, so I'm covering the APAC time zone for this event. And I'm now focusing on talking about the technologies and products for the embeddings and vector search and how it could be related to the LLMs and Gen AI. So yeah, we'll be spending another about 1 hour or more to going through the notebooks. I'll be using notebooks rather than the code lab for explaining what is the embeddings and what is vector search and what kind of the code you would write to access those technologies. Okay, let's get started. So as I mentioned, I'll be using, unfortunately, my notebook is not available on the Quick Lab or the Skills Boost yet. So if you want to try the code I'll be showing, you can go to the GitHub and open the generative AI repository. Just open the for example, if you go to the GitHub and search for the generative AI, so that there are some Microsoft Stability AI repository, but you can find Google Cloud Platform Generative AI repository here. So that's our repository. And also you can find the same link on the Startup School repository you're opening. So click that. And this is the repository where we collected many notebooks for trying out the Gemini APIs or Palm APIs and different technologies. So you can take a look at if you are interested. Like, for example, we have the latest notebooks that features the Gemini API. That is the latest the multimodal AI models we announced recently. And there are some search folders, conversation folder, and so on. So today I'd like to focus on the embeddings. So you can find my notebook in the embeddings folder. And this is the notebook we'll be using intro, text, and vector search. By the way, we have a couple of the other notebooks. For example, this vector search quick start notebooks. This is the minimum shortest notebooks you can try to just get started with the vector search product. But for this particular sessions, I'd like to use this one because it has a more introductory content, many demos and some images, diagrams inside the notebook. So you can use it for learning about what is embeddings and what is the vector search. Let's get started. So when you are opening these notebooks, you'll be seeing this introduction. So in this tutorial, we'll be learning what is the embeddings and vector search and how you can use them to bring the power of the large language models to enterprise systems. Or the embeddings, understanding text with the Vertex AI text embeddings. So we'll be using two products from Vertex AI. Vertex AI is the AI platform in the Google Cloud, and we'll be using two products. First one is the text embeddings. This is an API for extracting embeddings. It's actually just a bunch of the numbers, real numbers, like about 700 numbers you would get for representing the meaning of a single text sentence. That's the first product. The another product we'll be using is the Vertex AI Vector Search, which is to take those embeddings. For example, you can put like a 1 million or 110 million or more than billions of the embeddings dumped into the vector search so that you can use the vector search to find the embeddings in milliseconds. Actually, the latency could be like 20 milliseconds or 50 milliseconds or less than that. So it's super fast. So that you can build the entire grounding, so-called grounding. I'll discuss what is grounding later. The solutions using the power of the LLM. And actually, if you're interested, you can also refer to the blog post. I've written this blog post first and then convert it into the notebook later to add it with the sample code in it. So if you're interested, you can also take a look at the blog post version of the same content. So going back to the notebook, and this is a Jupyter notebook, so that you may have to have some basics of the Python programming and the basic of the machine learning, how to use the Jupyter notebook environment. So if you don't have those experience, yeah, please take some YouTube, please watch some YouTube videos or the Google for it, learn the basics about Python, machine learning, and the Jupyter Notebook. And also, this requires a billing account, Google Cloud project with a billing account. Unfortunately, for these sessions, we'll be using your own project, not QuickLab, so that you have to take. We have to be aware that by learning this code, I will be discussing. I'll be explaining. It would take some money. Actually, it's going to be like a few dollars, like $2, $3. Actually, in my case, when I tried this, I got like a $1.5 or something like that. So it's super small, but still it costs you some money for your billing account. So please mind that. And these notebooks can be run on either Google Colab or a Vertex AI Workbench. Colab or Colab Enterprise could be used. But for this session, live sessions, I'll be using the Vertex AI Workbench. So let's get started. To use Workbench, if it's the first time to use Workbench in your Google Cloud project, open Workbench console. Because I'm using my own project and I already enabled the Workbench, so it's already there's already an instances running on inside my console for the Workbench. But for the first time users, you'll be seeing some buttons like enable API kind of buttons. So please enable the service, and then after enabling this service, you can click the other link. Yeah, you will find this link. Then click this link and select existing notebook or create new notebooks. And this link can be also found in the this one. Yeah, open in the Vertex AI Workbench. Has the same link as this one. So either link can be pressed. So let me try that. Then you will see the console for the Vertex AI Workbench. By the way, Vertex AI Workbench, I forgot to explain what it is. It's just like the Colab. So Google Colab is a free environment you can access to run your notebook on the cloud. But if you want to use the Jupyter Notebook for your production development, or if you want to have your own instance running on the Google Cloud environment with some any instances you specify, like if you want to use like a 16 GPUs attached to an instance, the notebook instance, you can do that with the workbook by specifying the instance configuration. So it's a commercial environment for the Jupyter notebooks running on the Google Cloud. And if this is the first time for you to use the Workbench within this project, then you may have to create a new notebook like this one. And you can just click the create button and everything is as default. Because for this notebook, for this session, I will be not using any heavy-weighted calculation that requires CPUs. So the basic instance with the 4 virtual CPUs, 16 gigabyte memory is enough with TensorFlow, the images for the continents. In my case, because I have created the notebook instance before, so I'm choosing this instance to deploy the notebook. So you'll be seeing this kind of the what is that dialog, not dialog, confirmations. That by pressing the confirm button, you'll be deploying this notebook on the GitHub on the Workbench instance. Let's click that. So wait for maybe 10 to 20 seconds. You'll be seeing the Jupyter notebook environment opened. Be patient. Okay, got it. So this is the screen you'll be seeing. So it opens the notebooks from the GitHub repository. And this is exactly the same notebooks. And now you have the runtime to run this notebook. Okay. So as I mentioned, you have to pay a little money for running this notebook on your Google Cloud project. How much money and what is the what's included in that total cost? So actually, you have to spend a little money for the embedding for text API and the vector search API and BigQuery for taking the making a query for retrieving the sample data set. And because we will be using the cloud storage as well, and Workbench also itself takes some money. But still, after going through all the notebooks, when I calculated the total cost, it was something like the $1.7 for single trial. So you don't have to worry much about the cost, but you have to worry about deleting your objects. This happens all the times whenever we have any the workshop with the build account environment. Some of the attendees or participants in the workshop could forget about deleting your object. The easiest thing you can do is shutting down the entire GCP project, Google Cloud project. That is the easiest thing. If you cannot delete the Google Cloud project, the thing you can do is delete all objects, like a Google Cloud Storage bucket, delete vector search indexes, or I think those are the things. But anyway, there's at the bottom of these notebooks, there are a bunch of the code to delete everything. So you have to make sure that everything is deleted, or you had shut down the entire project. So that otherwise, I've seen some cases that some participants would be charged for like $1 every month or something like that for the cloud storage or something. But anyway, going back to the topic. So bringing generative AI and LLMs to production services. So what are the challenges to bringing the LLM into production? How to integrate LLMs? Or maybe I can make this larger, so easy to read with the larger font. Yeah, that's it. So how to integrate LLMs or AI chatbots with existing IT systems, databases, and business data. This is so-called grounding. I remember that it was like in 1980s when I learned the word grounding for the first time. So grounding has been a long-time problem for the machine learning and AI since at least 80s. That's when I heard the word for the first time. Back in the 80s, only a few people were using the machine learning and neural network. Instead, they were using something like logic programming with the Prolog language to build a so-called expert system with a bunch of rule-based systems. But still, they were kind of building some kind of the AI model. And nowadays, we are using LLMs as the AI model to build the AI-based systems. But we share the same problem with the AIs in the 80s. How to connect the AI model with the real world, especially the databases or the existing IT system. That is so-called grounding problem. So this is not a new problem. So you know that by playing with the BART or maybe ChatGPT, you know that LLM is smart enough to have smart conversations or smooth conversations with humans. But how you can utilize the power of the LLMs with existing IT systems with my own MySQL databases? That's the one problem, grounding. We have thousands of products. How can I let LLM memorize them all precisely? So as you have learned in the past courses or in any external courses, LLM is just a kind of the probabilistic model. It's not something like the databases. So in theory, it's impossible to 100% to get 100% accuracy on memorizing things by LLMs. As long as it is using some machine learning technology or deep learning technologies, you always have some small risk of having a wrong answer from LLM. That is so-called hallucination. Sometimes LLM makes things up. So it's not a database. But the user experience or user expectation is something like the database. Why not using the MySQL to get the 100% accurate record from the enterprises? And so that's the limitation of the LLM. So the LLM cannot memorize and remember everything's 100% accurate. So that's the problem, especially when you have like thousands of products in your e-commerce website or millions of products. There's no way to let the ChatGPT or bard.google.com to memorize and remember exactly what are the product features or out of the millions of the products you have in your enterprise. It's not possible. So you have to combine the existing database with the LLM. How to handle the hallucination issue with the AI chatbot. So hallucination, I don't talk much about hallucination, but you know it. Those LLMs makes things up. That's the problem. So here's a quick solution, grounding. So you are connecting the LLM with the actual IT systems by using two technologies. One is embeddings and vector search. This is the topic we'll be looking at. Before learning the concepts like the embeddings and vector search, I'd like to take you to the some demos. I don't know why it is happening, but in the Workbench environment, how HTML links are not in the blue color. It is shown only when you hover your cursor over the link. So it's really unuseful, but still, yeah, this is the link. This is the demo available as the public demo. So if you click it, you can actually access the live demo. This is a public demo, so anybody can try it, and you can share the link on the Twitter or something. Where you have the three demos, I'll be showing the first demo, Stack Overflow demo. This is a demo where we have imported 8 million pairs of questions and answers from Stack Overflow website. As you know, Stack Overflow is maybe the one of the most popular question and answers website for the developers. So on Stack Overflow, they have collected over like tens of thousands of tens of millions of the pairs of questions and answers. And those answers were answered by the human expert, not the AI generated answers. So we have the public data set that is imported from the Stack Overflow on the BigQuery. BigQuery has a public data set. So anybody can access the BigQuery public data set only by spending the cost for the query. And we have imported 8 million rows of the entire data set. And you can make a query on it. Like, it should be some programming or developer related questions like how to shuffle rows in SQL. Then, as soon as you and typing, you would get the answer in like 0.1 seconds, like 100 million seconds or 200 million seconds. It's super fast compared to the time you have to wait to get the answers from the ChatGPT or Bard. I'll explain why it could be so super fast. So you can see those are the questions. So I'm searching for the similar questions by typing the questions. So the demo is doing this something called similarity search or semantic search is the other questions. And the point here is that the demo is not using the keyword search at all. So the meaning of the semantic search is that it takes the meaning of the question, how to shuffle the rows in SQL, and try to find the other questions that has a very similar meaning as the sentence. This demo doesn't look at any keyword or it doesn't any keyword match. So that's the most interesting part. So by clicking any one of those questions, you can open the actual Stack Overflow question and answer page. So this is not the AI generated page. All you are seeing right now is the real business data. So there's no hallucination happening with this demo, although it uses the power of the LLM. So I'll explain this. I'll explain why you can do that. Okay. So going back to the notebook. So before discussing why you can do this kind of similarity search without any hallucinations, I have to explain what is embedding. Every time I start talking about the embeddings, I would ask the people attendees in the event or the meetups, how many people have heard about embeddings? How many people are using embeddings? Usually, only a few people are using embeddings right now for building their IT systems. I believe that 99% of the existing IT systems doesn't use embeddings, but still, 99% of the internet users, including yourself, including myself, are using embeddings every day. Like, maybe dozens of the embeddings and vector search systems every day. It empowers the most, the modern web services from Google, not only from Google, but also the services like Spotify, TikTok, or the Facebook, Instagram. Almost all the big techs and major internet services are using embeddings and vector search as a core part of the internet services. So as I mentioned, the 99% of the existing IT systems are not using embeddings. They are relying on the tabular data on the MySQL or Oracle or maybe Excel spreadsheet or Google Spreadsheet. Anyway, IT engineers have been organizing data by using the tabular data, and that limits the whole user experience for the users. For example, if you go to the IT department of your enterprise and ask engineer, can I find the product by using some the text query? Like I'm looking for a T-shirt with a print that has the print in this taste or this character. The UX designer or UI designer or product manager of the e-commerce website want to take some ambiguous query from the users and have the applications, e-commerce applications, behave like a human consultant or staff in the those fashion item shops. But you cannot do that because as long as you are using the relational database or the tabular data search engines using tabular data, because every data is organized by the keywords, strings, or tags or labels or categories. That limits those, tabular data on labeling keywords limits the user experience. But if you remember the user experience you are having with for example, YouTube recommendations, YouTube Shorts, I myself am a big fan of the TikToks. I usually spend like 1 hour every night just for, swiping the videos. And I'm also a big fan of the Spotify. Somehow that dynamic playlist reflects my taste on the music. They know my taste more than myself. How do they do that? By using the database. Actually, they have the databases, but they are not using the databases for tabular data for those recommendations or such. They all using embeddings that is generated from the deep learning models, or sometimes nowadays we can use the LLMs for generic embeddings and vector search that I'll be talking about later. So most of the latest modern internet service and user experience is powered by embeddings. So that's why the learning about embeddings is super important, even for the business people. And what is embeddings? So embedding is always generated by the AI model, deep learning model, or LLMs. Or maybe you can use much simpler models to generate embeddings. But anyway, once AI is trained with a certain data set like documents or the images, any kind of the content, or any kind of the business entity like users with user profiles, user activities, or products with the product, the attributes of product, the history of product stock data, something, anything, any business data. If you can design a deep learning model that can understand the meaning of your contents or business entity, that model can build a so-called embedding space. It's like the entire database instance you have on the MySQL or the Spanner. Instead, AI builds an embedding space where the AI, the deep learning model, can organize everything, every entities or the contents. Indeed, that's huge space. It's a map of meaning. For example, this is a super simplified example. Think of the three-dimensional space. The one dimension has the movie, another dimension music, the third dimension is actor. And if you have a single content like a document that talks about movie for 10%, music about for 2%, and talks about actor for 30%, then this is a super simplified example, but the one AI can generate three numbers, 0.1, 0.02, and 0.3, and define a position in the three-dimensional embedding space. This position or location is embedding. So what's the benefit you could get with the embedding space? Because by building that kind of embedding space, it's super easy to find similar content by meaning. Because AI understands the meaning, and by using LLM, it can understand the meaning of the text or images, just like humans. So it's super easy to find very similar images or videos or anything just by looking around the neighborhood of a single location. So that's how those people like Spotify, TikTok, Google, the most major services from Google, every services are using the same technology, embeddings and AI models. So that's the reason why you can keep continuously watching the fun videos on YouTube Shorts. And nowadays, those models are updated real time, so that whenever it senses by the timing of the swiping the videos, it can sense that this particular user is getting bored with the cat movies anymore. Cute cat movies could be more maybe bored, so that why not showing the other kind of the cat movies, like cats in trouble kind of the videos. You can find many the videos where the cats are in trouble, like messing around in the entire room or something. Just by walking through or navigate in the entire embedding space. So there are some spaces in the huge space. There's a small space for the cats videos, and there are some smaller subspaces for the cute cats or troubled cats in troubles kind of videos, or cats in the miserable situation, like left in the rainy outside, that kind of thing. But anyway, so by using the embedding space, you can represent almost infinite number of the small categories or labels or nuances or taste of the content. And in reality, at Google, we are using the embedding space with the 700 dimensions or 1,000, 2,000 dimensions that can represent almost infinite number of the meaning of the content, subtle nuances that could be only understood by the humans in the past. Now you have the LLM that can understand the subtle nuances of each content and represent the meanings by using the embeddings. That's the most interesting part of the using embeddings. Google Search, YouTube, and Play, and many others, Google is powered by embeddings. And this is not only for Google. And please note that this innovation of the AI and embeddings and vector search has been happening for last over 5 years already, less than 10 years. And yeah, I have been watching those papers for deep learning based the recommendations or the information retrieval that uses embeddings for last over 5 years. So this is not directly related to the innovation of the LLM. But in the past, the reason why the embedding and vector search has not been so popular is that it was really hard to build your own deep learning model to generate the embeddings to solve your business problem. So you have to hire a couple of the cutting-edge data scientists that can read all the papers for the Lexis recommendation systems or information retrieval and build a beautiful embedding space for you. So this technology was something you can now use easily. But for last couple of years, the booming of the use of the embeddings and vectors search in the LLM community started last year. Suddenly, it gets super easy to create your own embeddings by using LLMs, because the LLM providers on the cloud provides the API to turn the text or images or whatever into the embeddings by calling the API. So you don't have to design and train and deploy your own model for getting embeddings anymore. So that's the reason why we are facing with the sudden surge of the popularity on the embeddings and vector search. But anyway, the thing is that by using the embeddings, in addition to the traditional databases, you can significantly enrich the user experience by having the AI understanding the meaning of the content, just like humans. And if you are interested about embeddings, there are great contents already. So if you go to the Google Machine Learning Crash Course, there are great chapter talking about embeddings, especially for the recommendation systems. And also, my colleague Dale Markowitz written a great post, Meet AI's multitude of vector embeddings. She talks about text embeddings in the blog post. So please take a look at those materials. And also, my colleague Nikita did a great job on posting content on the deeplearning.ai content. So there are great materials to learn about embeddings. So to use the embeddings, the easiest way for you as a Google Cloud user is to use the Vertex AI embeddings for text. You can easily create a text embeddings with LLM. The product is also available on the Vertex AI model cloud. Okay. And I'll be showing what kind of the code you should write to call the API to get embeddings later. So before that, let's discuss about, so what are the benefits, or what kind of the application you can use for with the embeddings. The one use case is apparently, as you saw on the demo, LLM-enabled semantic search. So as I mentioned, semantic search is not a keyword search. In many cases, actually, in production system, you have to combine semantic search with the keyword search. Because in some cases, for example, if your user want to find the products by looking at the product number, because the product number doesn't make any sense even to humans, so you always have to use the keyword search. Or some users still want to use the exact keyword match when looking for some products. So in production systems, like Google search, are combining both semantic search and the keyword search. By the way, Google search has incorporated the semantic search at, I think it was 2016 or earlier than that, with the technology called RankBrain. You can Google for it. The RankBrain Google search shows the results blog post. So we have been using the semantic search technology for a while, and we keep upgrading the deep learning model behind that. So Google search is getting smarter and smarter. But the Google search has been also evolving the existing token-based, keyword-based search engines as well. So it's a hybrid search engine. Another use case for the embedding is the text classification. So if you have a knowledge with the basic of the machine learning, you can easily create your own small MLP, the multi-layer perceptron was it? Okay, MLP, very small model can enough to learn to do the classification with the embeddings. Whether, for example, this voice from customer is saying any positive feedback or negative feedback, just like that. Or is this a Japanese text or the English text, or just like that. Recommendation is quite different, a little bit different from the search. For example, if you are building an e-commerce website and you may want to do some recommendations with the search query, not just looking for the searching for the products that matches with the query, but also you may want to add some upsell products or recommended products or cross-sell products based on the personalized data, right? For example, a user has some Google Analytics logs, and you know that this particular user is interested in purchasing some fashion items with this kind of the booths. Then you may want to add some other the variety of the booths in the search result. Or what else? Yeah, or purchase history. User would have some purchase history, some items in the cart. So recommendation has a quite different requirements compared to search. So for that purpose, you may want to train your own tutor model. That is a popular recommendation model by deep learning. That takes the text embeddings generated from the LLM, added with some other product, the embeddings or so on, to build a very high precision recommendation system. So, and these are only a few examples of the possible the capability or use cases for the embeddings. And in these sections, we'd like to actually see how the real embedding space look like. And we have worked with the startup called Nomic AI. They are really good at visualizing the actual embedding space. So let's try it. And again, you have to find the where's the link for try it. So try exploring it here. So by pressing the button, you can open the Atlas Nomic page. And we have collaborated with the Nomic AI. So they provide the visualization tool, and we provide the data set and with embeddings. So what you're seeing right now is the embedding space that has the 8 million items imported from the Stack Overflow. So as you can see, there's some labels attached in each cluster in the cloud. So for example, if you go to the cluster for the databases, join, there's a cluster for join. So each single dot represents a single question on the Stack Overflow. So on the left-hand side, you can see the question title and question body. And by choosing the other dots in the neighborhood, you can find similar questions on the Stack Overflow by its meaning. So it's just like the LLM, the text embeddings API, and the LLM model behind that has the common sense as a programmer, human programmers, and who knows about what is join and what kind of the questions could be join question. He knows that or she knows that. So it's just like a human programmer sorting out all, examining all the 8 million questions and looking at them and sorting out those questions in the entire space. Like a librarian, it's a huge library with 8 million the questions, and there's a person who are organizing everything into a smallest categories, right? With humans, you cannot do that, but with LLMs, you can do that. This is the result. Okay. And as I mentioned, it has a human level intelligence in it. For example, in the second row, we have the questions like, does moving the request line to a header frame require an app change? When I saw these questions for the first time, it doesn't make any sense to me because I didn't know anything about the changes happened on with the HTTP2. But the LLM that is used for generating these embeddings knows that, oh, this is a questions about HTTP2 because they have changed the header frame from 1.x to version 2. So the LLM put these two questions closer in the embedding space. And it can also understand the semantics of the programming code. Here at the last row, there are a program sample code for writing a fizzbuzz kind of code. And also they are using different the variable names and with different parameter values. Because LLM can understand the semantics of the program, that means the intention of the programmer. So the LLM thinks those two codes could be similar in their meanings. And, because this is a generic large language model, I have not trained the LLM for the programming purpose or the technology purpose. You can use the LLM for getting the embeddings for any kind of the different verticals, such as the, for example, financial industry or any industry, automotive, technology, engineering, or the medical, or anything. So it could not be as cutting edge as the human expert, but we can expect that LLM has an average knowledge in that area, expert. So that's the innovative part of the LLMs. Without training the model with your own data set, it already pre-trained with the generic common sense and knowledge in the many different industries. That's the very innovative part. So that was the explanation of the text embeddings. So let's get started actually using the text embeddings in your sample code. So to set up the whole environment to get started with the embeddings, you have to install the Python SDK, the Vertex AI SDK. You have to set a few environment variables. And if you are using Colab, you have to go through the authentication process. For the Workbench, because the notebook is already authenticated, so there's no authentication required. And, if it's the first time for your project to use those APIs, you have to enable APIs. And if it's the first time for you to use like a BigQuery, Cloud Storage, and Vertex AI with those service accounts, you have to set the permissions. So let's get started. So at first, you have to install the SDKs. Maybe you have seen this many times if you have experience on the other Vertex AI APIs. So every time we do this, and after installing the SDK, you have to restart the kernel. So by running this, you see the kernel is restarting. So now kernel is restarted. So you can get started. You can start using the SDK. You have to set the project ID and location environment variables. But in case of the Vertex AI Workbench, it's super easy to get the current project. You can just run this code to set all the required project ID. And UID variable is used for time stamping for each run of the cell. If you're using Colab, you can use this code to get the authentication. After that, you may want to enable API. So we'll be using the Google Compute Engine API, AI Platform API, Storage API, BigQuery API. You have to enable those API and also set permissions. And to do so, you open the IAM page. Again, this is a hidden hyperlink that is kind of hidden in the Workbench environment. And when you click it, you can open the IAM page for your project. And since I have been running these notebooks a couple of times, I have already set the roles for this Compute Engine service account as BigQuery user, storage admin, and Vertex AI user. Those are the 3 roles you have to add to the Compute Engine service account. You can find the Compute Engine service account by looking at the those compute at something and with the project number in it. So project number -compute is the Compute Engine service account that will be used by the notebooks on Workbench. So after adding those permissions, you can get started with the tapping the APIs. So at first, we'd like to download the sample test dataset from the BigQuery. As I mentioned, the Stack Overflow dataset is a public dataset available on BigQuery. So anyone with the Google Cloud account, with the billing account, can use the table for trying out the queries. And it has the 23 million rows in it. It's too big. So we are limiting to the 1,000 rows. So by running the BigQuery query, like, taking 1,000 rows from the post questions table, and I have ordered those questions by view count. So we are fetching the most popular questions and looking at importing them into the pandas data frame here, and looking at the head of the data frame. So these are the sample data set we'll be using. IDs, it has IDs, and titles. This is the question text, like how to use nested map. Can I enroll users? So blah, blah, blah. The next things you want to do is the taking these strings from the title column and pass it to the embeddings API. First, you want to initialize the Vertex AI packages. You'll be seeing this kind of the warnings for the loading TensorFlow, but you don't have to care about them. As long as you have the code finished, then it's okay. Then you can import the text embedding model. This is the class for the embedding model that is loaded. And in this code, we are using the text embedding -gecko 001. This is the formal name of a particular embedding model. There are other couple of the models you can use. For example, if you want to use, for example, any languages other than English, like Japanese or Chinese, there's other model names for the multilingual model. So please take a look at the document for the details. And also, there's some other caveats for using this model. For example, it can take the request for converting the text into the embeddings up to 5 text in each call. But there's a quarter for this call. That is a request per minute quarter. And that is set to the 60 per minute. That means 1 call per second. Pretty low quarter for all the new cloud project. But if you have some cloud project, if you're using some cloud project that has some usage history, then the quota will be automatically increased for the 600 per minute, like 10 calls per second. And because this is a quarter, so you can anytime request a quarter bump, like I want to use the 2000 QPS, 2000 calls per second for converting the millions of the rows into the embeddings. You can do that by sending a quarter bump request from the UI. So in many cases, you may want to write a small wrapper function like this that handles the batch processing and also do the throttling. You don't want to tap the API faster than the quarter limit. In this case, because this is a quite new project, I want to limit the speed of the calls 1 per every second. So I inserted the sweep for 1 second and call the models get embeddings call for each 5 text sentences. Okay, so that's the wrapper. And with this code, it is getting the list of the all question sentence and get the embeddings for those questions and add it as a new column in the data frame by using the assign function. And yeah, actually, this is a live demo, so it will take like less than 4 minutes to encode all the text into the embeddings. And actually, I'm in other projects, I'm using demos for the upcoming the Google Cloud Next in Las Vegas in April. And for demos, I had to extract the how many was it? Like 6 million rows of the embeddings for images. There's another API for taking embeddings for images, multimodal embeddings. So to do so, I had to raise the quarter up to 2,000 calls per second, so that for converting 6 million images to embeddings took about 3 days, I believe, 3 or 4 days. And yeah, while I'm waiting, we are waiting for finish creating embeddings. I can talk about the real world problems. So problem when you are converting the many millions of bit rows into the embeddings would be, you may have to think about the throttling, and adding the sleep call would be the easiest thing you can try. But sometimes for some APIs would have some latencies, so you don't want to, take this extra sleep. So in my case, I used the threading of the Python. So for every single call for the API, I created a thread. And it's a worker thread. So I have the main loop where it spawns the new worker thread for every single query to the API, and spawns like 2,000 threads every second, so that you can keep the quarter limit as intended. And it works so well for my case. So that's the maybe one tips you can use for dumping the bunch of the items into embeddings. Another way is the using the BigQuery ML. So as some of you might know, BigQuery, the data warehouse from Google Cloud, has some other the machine learning functions that could be used in the SQL to convert existing text into embeddings. Yeah, I can look for it. Yeah, for example, BigQuery ML embeddings. Using text embeddings. Yeah, this is it. So it's super handy. So you don't have to wait for calling your API for getting text embeddings. Actually, I would use it. So just by calling this function from SQL, from BigQuery, you can get embeddings for the large table without writing any loops or threading with the Python code. So this is much easier way to convert the data into the embeddings. Okay. Okay, looks like we got the embeddings. Now you can see the ID and the question title and embeddings. Embeddings has in this API, it has the 368 numbers in it. So it's a vector. It's actually a vector. The embeddings is a special type of the vector. So it's just a bunch of the numbers that represents the meanings. So what do we do with the embeddings now? So as I mentioned, what you want to do is to find a neighborhood in around a single location embeddings in this space. And it's not so hard to do so. You can just calculate the distance between the vectors. There are a couple of the different ways to measure the distance between vectors. One is the L2 distance or Euclid distance, just measuring this red distance. Or the another popular way, maybe the most popular way, is to calculate cosine similarity. Calculating the angle that is made by the two different embeddings vectors. And the third one is inner product. This dotted line. This red line is inner product. So, and you have to check out what kind of the model you would use and what kind of the those matrix you should choose. And in many the open source based model case, the embeddings should be measured by the cosine similarity. But in many cases at Vertex AI, you can find in the document that you should use inner product to measure the distance between those embeddings. So in this case, we'll be using the inner product. Text embedding gecko, the model text embedding gecko 001 recommends to use the inner product, dot product, to measure the distance. So before diving into the vector search technologies, let's do that by your own code, simple and naive code, using the NumPy. So in this code, let's trying out calculate the similarities or distance between the two embeddings. First, it picks one of the 1,000 items as a key questions randomly. And then calculating the dot product distance between the two key and other the 1,000 or 999 questions by using the np dot function. And take a look at the first 5 examples. Do that. So this is the result. Seems like the first one is almost identical to the key question. The second one, 0.59. The third one, 0.6. So these are all the distances measured with the key question. So just, all you have to do is calculating all the distances with the 1,000 embeddings and sort them by distance. Okay, let's do that. So this is the result. Key question was how to use nested map. And the first closest, the result is how to nest enums in TypeScript. How does merge processing do pickle maps? Yeah, seems like it's, retrieving a very similar answers. Let's try another one by rerunning the same cell. Picking another random questions. This time it's about problems with the CSRF token logging Scrappy. So it seems like, the model understands it's about some HTTP negotiation, CSRF kind of the certification kind of the problem. So it gets the other questions with the same topic, right? So this is the how you can use the embeddings with the by calculating the distances. Okay. So lastly, I'd like to take a look at how you can use the vector search for doing the calculation of the distances. So as we have seen in the examples, it's not so hard to calculate distances between embeddings. It's a kind of high school math kind of the calculations. But thing is, if you have millions of the rows with the 700 dimensions, 700 numbers in it, the order of the calculation, the computation complexity will be order of 1 million times 700 dimensions. Or it could be 1 billion times 2,000 dimensions. So actually, when I was, have learned about the vector search like many years ago, like 6 years ago around, and I wanted to try it on BigQuery, and I did it. I implemented the same algorithms as we have seen with the BigQuery user-defined function with the 1 million image embeddings taken from the CNN model. And it took like 20 seconds to find similar images or single images by using BigQuery. BigQuery is super fast, but still it takes 20 seconds. So if it takes like tens of seconds for each query, it's useless. So instead of using the naive, brute force search, researchers have been studying a technique called approximate nearest neighbor, or ANN, for faster search that uses so-called vector quantization technique. And this is in a nutshell, it's similar to the database indexing in RDBs. So with the relational databases, you have to add the indexes for the important queries so that the indexes can build a tree structure like a B trees or the variations of the B tree algorithms, tree structures to find out the records in the databases. Just like that, ANN as the tree structure to the divided areas, clustered areas in a huge embedding space, so that you can find the certain area of the specified embeddings in milliseconds. It's super fast, but please note that this is approximated result. So the problem is that you cannot always get to 100% accuracy. There's always there could be always risk of missing some small part of the entire result. So there's a trade-off between the that recall rate, the accuracy, and the latency. So researchers has been studying and trying to find the fastest ANN algorithms that provides the better result, like a 98% recall, 99% recall with the shorter latency, like 10 milliseconds or 20 milliseconds. And Google research team has published Google's latest ANN algorithms called SCAN in 2020. This is still among the best ANN algorithms in the industry. And this is the foundation of the entire Google business right now. Almost all Google services, including Google Search, Google Maps, Google Ads, YouTube, they are all dependent on the SCAN. We have one of the largest vector search and the infrastructure backend at Google, and they all use that with the scalable and available vector search. So also there's some open source implementation of the ANNs, or maybe the cheaper or inexpensive the products from the other vendors. While if we want to take the advantage of the Google's vector search technology with the highest scalability and availability, you can do that easily by just turning on the Vertex AI vector search, because it shares exactly the same technology. So that's the reason why you may want to take a look at the Vertex AI vector search. You don't have to build your own ANN infrastructure from the scratch. The hardest part is building a data pipeline for the updating the production vector search index. That is the hardest part, but you don't have to worry about that because everything is already there. And all you have to do is tapping some simple APIs, and we are doing that. So at first, you have to save all the embeddings in JSON file on the Google Cloud Storage, build an end index, and then create an index endpoint so that you can deploy the index to the endpoint. Let's take a look at that. Sometimes I experience when I try the notebooks with Colab, sometimes because especially the deployment for the vector search takes like 20 minutes or 25 minutes. So sometimes you would lose the Colab instances. In that case, you can use the utility, the code I have prepared at the bottom of this notebook to get those objects for the index endpoints and indexes. So please look at the utility sections in that case. So at first you have to save the JSON file. So we have now 1,000 rows of those embeddings and ID numbers. Yeah, 1,000 rows, and you are copying them to the bucket. That's it. You are ready to build an index for on the Vertex AI search, Vertex AI vector search. Initialize the AI platform's SDK, and calling the create tree AH index. Tree AH is the name of the algorithms they use inside the vector search. By the way, matching agent is the older name of the product that has been called as a matching agent for some years, like 3 or more years. But recently they have changed the name to the vector search. And this to build index, you have to specify the bucket of the embedding file. And also you have to specify what is the dimensions of each embeddings. And you have to specify roughly in average how many neighbors you may want to fetch in a single query. And you have to specify what's the measurement way for measuring the distance between the embeddings. In this case, as I mentioned, we'll be using dot product. So for the smaller index that has less than 100 megabyte, it should finish building an index should finish within like a few seconds as we saw. But if it's larger than that, you have to wait for 1 hour or 2 hours. In my case, for the 6 million rows, I believe it took like 2 to 3 hours, maybe about 2 hours. And you can always, check out the console for the vector search, where you can watch all the status of the different index and endpoint status. Okay. And there's also another API called streaming updates, where that allows you to update each rows in the index in real time. For example, if you have the e-commerce website that have to update all the embeddings all the times, every day or every hour or every minute, then you may want to look at the streaming update. It's super handy because you can update any entry in the index almost within 1 second. It's super fast. And lastly, you can create index endpoints. That works as a server instance for your embed index. And that takes the request for the vector search. And finally, you can deploy the index on the endpoints. And this should take like 20 minutes at least. So I can show another example where I have already deployed the index to the endpoint and run a query. So you can try the query by taking the test embeddings. How to read JSON with Python is the test embeddings, and calling the find neighbors call with that test embeddings, and you can specify how many neighbors you want to fetch so that you can get the answers like this. And even if you have like hundreds of millions of rows in the index, the latency should not change significantly. You always get the result within tens of milliseconds or hundreds of milliseconds. It's super fast compared to the database search or keyword-based search. Why am I unable to process JSON data with Python 3? Again, it is not using any of the tokens or keyword matching for this search. This is all done by the intelligence of the LLMs represented in the embeddings. Okay. So lastly, there's a part where you can, run this code to quick clean everything to avoid an unexpected payment. So I'd like to look at those few sections to wrap up. So we have seen all the entire grounding solution. So grounding could have multiple solutions. The solution with the simple embeddings and vector search is maybe the simplest embedding solution. But as you may have heard the new buzzword called RAG or RAG, Retrieval Augment Generation, you can extend this simple setup to have the LLM generating the output, the result in the natural languages. This is something called RAG. But for deploying those grounding systems to the production, you have to be aware of some caveats for those information retrieval. Because this is just a similarity search. In this case, we have used the Stack Overflow dataset so that you can find similar questions, existing questions, by a user's questions. But in many cases, you don't have the pairs of the questions and the answers already. In many cases, you have to have an AI model, deep learning model that learns the relationship between the query and the recommended items. So that's where you may want to build your own recommendation systems, or you can do some prompting with the LLMs to use the LLM reasoning to make the leap between the query and answers. So this is the reason why many of the simple RAG systems are facing with the search quality problem. They are using the simple semantic search, similarity search, for finding answers, and usually it doesn't work. And as I mentioned, you may want to combine the semantic search with keyword search. And what about RAG? I don't. Maybe there could be another. Yeah, there's another sessions for the RAG. So please take a look at how you can build RAG. But the point here is that there are pros and cons between those two solutions. The embeddings plus vector search, the simplest semantic search, can work in milliseconds, whereas with RAG you have to wait for seconds, waiting for the LLMs outputting, generating the result, with some hallucination risk, and cost will be higher. But the user experience is much better. Embeddings plus vector search will be quite simple, and it doesn't look so different from the existing search engines. But it actually significantly increases user experience as the search service. So based on your business requirement, you may want to choose the solutions. Okay, so that's it. And there are many links for the documentations and the existing blog post. So please take a look at those resources. That's it. Thank you so much.
I was muted. Well, 3 years with the remote work, and I still make this mistake. I was muted. Sorry, guys, for this. Thank you, guys, so much for this. I'll let you grab a glass of water, take a stretch, and we'll get ready for the short Q&A. So in the meantime, we are presenting you guys a notebook this time. One more time, because I see this a lot of in the QA session. We're trying to answer this as well. There are two kinds of, let's call it the homework. The homework obviously is not obligatory, but we encourage you to do. There are labs on SkillsBoost platform that are very easy to access. You log in, you already should have this 200 credits over there if you followed everything, and you can start the lab, and there is a virtual console created for you for this particular project. Not everything is available in form of the labs. We are also making sure that all of these new things in the generative AI world will have eventually a lab, but it's much faster and easier to create a notebook. So for some topics, we don't have labs yet, but we have notebooks just as the one that Kaz was showing today. He was also showing how to access it from the very beginning, but that's true. You need your own environment. You need your own cloud console. Some of you are asking about the credits. The credits to SkillsBoost are different credits than credits for Cloud Console. And we're talking about cloud credits for Cloud Console. With your new accounts with Google Cloud, you can get this free trial that gives you $300 worth of credits. But also, for people like you, people working in startups, we have created Google for Startups Cloud program. And well, that's yet another great reason to join it. By scanning this QR code, by going to Google Cloud program, you will have all the information about our cloud program. This is mostly credits for startups. Depending on the stage of the startup, there are different amounts. There's something for Bootstrap and those that are VC backed. We have a special offer for AI first startups and Web3 startups. It's not only credits, it's access to Workspace, access to experts, to a startup success manager. There are additional credits for SkillsBoost, for Google Maps, and many, many more. All the information or the eligibility requirements are available under this link or under this QR code. So if you need credits and if you're working for startups, this is the way to go. This is the one that you should visit. With that, we have about 10 minutes left, and my fantastic moderators prepared a couple of questions that were asked very often. So I'll invite Kaz again to stage. Once again, thank for the great lecture. It was hard. I mean, for me, a non-super technical person, that was the moment of startup school where I finally felt, well, this is intermediate. This is not intro. This is, well, a complicated thing. But thank you very much for showing and describing everything with the great examples. Let's go with the first one from Christian. Can already generated embedding be updated instead of fully regeneration for data sources that are more fluid? That's the question from Christian Schade. Cass.
Okay, so in case you don't have to change the embedding model, then you don't have to fully regenerate everything. So for example, if you have an e-commerce website and you have updated some the descriptions about the products or product images, and you may want to update the image of the product, then you can just call the API just for the that items and update that embeddings to the vector search index. And that should be done by using the stream update API. It should be done within 1 second, instantly updated. But in case you want to change the embedding model, for example, in this case, in demo case, we have used the Gecko 001 model, but there's a Gecko 003 model already available. So if you want to do that kind of the update, you have to regenerate everything, because as far as I know, there's no way to have the compatibility between the embedding space from the different models. Every time you train a new model, even if it's a small fine tuning of the model, the entire embedding space changes drastically. So there's no compatibility between models.
Thank you. Thank you very much. Another one by Kaushik Nepali. I think it's interesting, especially that it tells us about the environment of these vector databases. So the question is, Quadrant, Weaviate, and Pinecone. I hope I'm reading these properly. So Quadrant, Weaviate, and Pinecone are trending on the vector databases world. How is Vertex AI different from vector storage standpoint when compared to these databases?
Yeah. So the reason why those startups and open source ANN implementations get popularity is, I believe this is my personal kind of impression, is that because the LLM community has learned the embedding is super useful. There's a multiple the embedding API from the OpenAI and Vertex AI, so that every LLM engineers can get started with the embeddings. And the open source implementations are very small. The products is a great starting point to get familiarize yourself with the concepts. But if you try to bring everything into production, that makes this story quite different, right? So you may have to build the entire data pipeline to keep updating the production, the index, and you have to have the very robust, scalable. By the way, the Vertex AI vector search supports the auto scaling out and scaling in. Scaling out, scaling in, scalability matters and availability matters. And also you maybe want to have the highest scalability that allows you to have the billions of the items with the millisecond latency. And the Vertex AI vector search uses a proven technology. It's proven by the billions of users every day that is used by the ANN technology, scan technology, the algorithms used by the billions of the Google search users, Google Maps users every day. So maybe it's going to be apparent that we have some advantages for the production enterprise use cases of those vector search technologies.
Okay, thanks. I think that's going to be the last one, and I love it because it's from Rui Ramos and is in the lines of my favorite movie director, Christopher Nolan. He's talking a lot about time in his movies. So how do we handle time dimensions with embeddings? There is an example of the use case. So the use case is to load alarms and other logs to vector database, and then ask a large language model what was wrong on a specific day or what actions have carried on a date. So but then basically how the time dimension can be handled with embeddings?
Okay, that's the same problem as how you can handle the time domain data, so like a time series data with deep learning models. So in the past, by reading the textbook for the deep learning, you can find various different ways to handle the time series data with the deep learning model. For example, Google Shopping or the product version of that was the retail search. And the recommendations AI is the cloud product that has the Google Shopping technology inside it, uses the Google Analytics logs, and takes some time series log from the Google Analytics, these are clicks by the users on the e-commerce website or something. And they extract the embeddings from that by using their model. And the easiest way to do that is to make a visualization of the time series data. For example, if you have the log data with error numbers would have sudden spikes in it, then just capture that screen and takes the embeddings from the screen. And that easy way performs very well for certain use cases. And the embeddings model can capture whether it has a spikes in the time series or not. So there could be the multiple ways to do that.
Okay. Thank you very much. When it comes to the questions that were, not yet answered by our experts, or that were, the most common one, I see this one. When it comes to the other databases, yes, the Pinecone was definitely trending as a vector database that people were asking to compare to. But I think we have covered it all. So with that, thank you very much. Arigatou gozaimasu,
Thank you so much
for that. And to all the rest of you, thank you for joining us today. Yet another startup school. We are in the middle. We are entering, let's say, the intermediate level with these classes. And next one is on Thursday, the very same time. We're going to be in February already. We're going to have Lavi with us, and it's a cool one, especially for all of you that are working with code on every day. We're going to talk about code generation, code completion, code chat, a lot of things that can make your life as a developer much, much easier, much more fruitful. So I highly recommend this one. This is the one that will tell you how generative AI can help you with the code. So I'll see you all on Thursday. In the meantime, you can do the homework. You can browse different labs on Skills Boost. In case of any problems, startupschool@google.com. You can reach me or my friend Luisa over there. Thanks once again for your time, and see you on Thursday. Ciao.